Welcome to the basic training you will need to operate the Epilog Zing laser in the BYU Idaho Maker Lab. This basic training consists of 3 modules. Module number 1 provides an overview of the laser. Module number 2 demonstrates how to create drawings for the laser. Module number 3 teaches you how to set up the laser and execute a job. Let's begin with module number 1, an overview of the laser, where you will learn the main components and the basics of how the machine works. Here is a photograph of the Epilog Zing laser, which is in the Maker Lab located in room 105B of the Austin building. You will be using the computer next to the laser to open your drawings and print them to the laser. The laser has a 12" by 24" build area, which is nice since many material vendors sell 12 by 24 sheets. This component here is an air compressor, which serves a very important function, which I will describe shortly. This switch powers both the laser machine and the compressor. The switch on the wall turns on the exhaust fan, which draws smoke and fumes from the laser up this exhaust duct and venting it outside. This is a schematic showing some of the key components inside the laser machine. The blue sheet on the bottom represents the material that's being cut, which is a 12" by 24" sheet. The laser is set up such that the default origin is located on the top left corner of the material, with the positive X direction to the right and the positive Y in this direction. The machine contains a CO2 laser tube located on the back of the machine and emits a laser light in this direction, which is reflected forward off a mirror to another mirror right here on the far left side of the moving gantry, which reflects the beam onto another mirror located on the cutting head, which reflects the beam downward through a lens and onto the material. The lens has a 2" focal length, which means the material needs to be 2 inches away from the cutting head so that the beam's energy is concentrated sufficiently to engrave or cut the material. Smoke and fumes result from burning through the material with the focused laser beam, which is why we need the exhaust fan to draw the fumes through the duct and blow them outside. The lens will last a long time if it doesn't get smoke and debris on it, but the exhaust fan is not enough to fully prevent this, which is why we also need this small air compressor, which blows air through a tube and out around the lens, which also helps keep smoke away from it. The laser cutter is a very versatile machine and can cut and engrave a large variety of materials, including wood, acrylic, and fabric. Notice that even though you can't cut glass with the laser, you can engrave on it, as well as on coated metals and ceramics. My son engraved a custom graphic on his grandmother's casserole dish, along with her name, so that it would be clear which was hers when she brought food to ward parties. You may also find it interesting that leather and fiberglass are on the list of compatible materials as well. There are, however, some materials that you must not process with the laser. PVC, ABS, vinyl, or other similar materials are absolutely forbidden. Hydrogen chloride or vinyl chloride are produced from cutting or engraving these materials, which are very harmful to your health and also cause irreversible damage to the laser machine. This is a page from the Epilog User's Manual, which contains recommended power and speed settings for various materials. A copy of this page is posted near the laser cutter so that you can conveniently see which types of materials are compatible and what some of the recommended settings are. If the material is not on this list, then do not cut or engrave it. Here are some additional safety precautions that you will be required to comply with in order to use the laser cutter. You must remain near the laser cutter when it is running, even if the job will take a long time. You need to be there in case something catches fire so that you can put it out. A fire extinguisher is located near the laser cutter, so make sure you know where it is. You will also be required to inspect the material support platform and make sure it is free from buildup. Cutting plywood creates a sticky residue which builds up on this platform and is semi-flammable. And you will also be required to clean up any debris that falls through the cracks of the support platform. To do this, you will have to remove the structure in order to clean underneath it. This debris could also catch fire and is a safety hazard.